Alright, hey guys. Just watched the last video. I realized that the mic lags a little bit when I'm up here, so it's kind of weird. Might not be able to do that in the future. I'm just gonna do the board videos today. I'll let Mrs. Florence know, but yeah, it's kind of weird when it lags. It really kind of throws you off a little bit because you see my lips moving, but then the words aren't matched up with them. It's like when a TV show on Netflix is lagging for you, if you've ever had that happen. But example two. Let's do it. What you need for examples 2 and 3, you need to have looked at the key idea number 2 on Canvas or in your book. It's the second key idea in the section. It deals with the distance formula. And the distance formula is used to find the distance between 2 points on a coordinate plane. So you can use it on you can use it on any 2 points that you're given. Just they need to be two ordered pairs. Um, so the distance formula is, we'll take our first step here. That should be your first step in problems where you're finding the distance between 2 points. The distance equals the square root of x2 minus x1 squared plus y2. I'm going to move that up a little bit. Y2 minus y1 squared. So it's the sum of these two, of the difference between x2 and minus x1 squared and y2 minus y1 squared. So our points, what points are we given? We need to find the distance between distance. Let's see if we can see that. Yep. Between, what is that? 1, 5 and -4, -2. 1, 5, -4, and -2. So we need to find the distance between these 2 points. This equation, the distance formula actually, it relates directly back to the Pythagorean theorem. That's kind of where it comes from. We'll see that in our example. Let's go through it. So we've got 1, 5, and -4, -2. We plug those in. We'll call this our first set of coordinates, and this can be the second. So then this will be x2, this will be x1, this will be y1, and this will be y2. So distance formula. I'm going to use a new color. It's to show that it's the start of a new start of the problem. All right, so d equals the square root. That stays the same. And then in these parentheses in here, x2. What's our x2? Let's look over here. This is our second set. This would be our x2. Minus 4, -4, and then minus x1. Our x1 is this one. That's our first set of coordinates. That's our first coordinate pair. So that's -1, and then that's all squared, plus, now we need to deal with the y values. So y2, which is -2, minus y1, which is right here, -5. Alright, now we simplify it even further. -4 minus 1 is -5. So -5 squared plus -2 minus 5 is -7. Alright, now when we square these negative numbers, they'll become positive. Okay, so we got d equals the square root of 25 plus 49. And that equals square root of 74. Now, that is our final answer. That is the distance between these 2 points, and since we weren't given any units, we just write the square root of 74. Alright, now we're going to do a real life example. For this one, I'll probably just do it on the screen in the book, so that we don't have to do it all on the board, because it requires a lot of drawing and be a really long video if we did it on the board. Plus it's lagging a little bit, like I said, so I think it'd be better if we did it just on the computer screen. Alright, so if you feel comfortable with a problem like this, actually, let me, one second. First step, you write the distance formula. Second step, you substitute in your coordinates. Make sure you do that. Then you simplify it and evaluate at the end. Okay, so you just add these and you get square root of 74. If this was like 64, then you would have to go even further, take the square root of 64, because we can do that evenly. That would give us 8. Okay? So if you feel comfortable with this kind of problem, move on to the on your owns. Otherwise, try watching the video again and look at the distance formula in the book. Look at the distance formula and your key ideas. That should help you out a lot. It also has a little bit more. It has the description. You can read along while we're doing this. All right, I'll see you guys in example 3.